Welcome back to my channel. My name's Brian Cafferkey. I'm excited to continue my series on Master Databricks and Apache Spark. This is lesson 8, which is using Spark SQL data definition language on Spark. Lesson 7 was using DDL, data definition language of SQL, on a Databricks notebook. So kind of showing you the difference. So this one, I want to really demonstrate the differences between using Databricks and using Apache Spark, but also mostly you're going to see a lot of similarities. So I do want to do that. So let's jump in. And by the way, I am drinking out of my Spark mug. To honor this occasion, this whole series, I kind of been drinking a lot of that, sometimes my Python mug. What are SQL data definition statements? These are statements which create, modify, drop, or query database objects. And what I mean by database objects are things like database tables, databases, views, and properties. Properties are actually kind of distinctive to Spark. It allows you to attach sort of name value pairs to different objects so that you can kind of document them really. We can also create, drop, or change partitions, and that's kind of very unique to the idea of scale out, right? The idea is on a scale out we have different nodes, and these nodes are basically processes which run in parallel. The data is set up into chunks, so it's broken apart, and each node will get a different chunk to process. When we talk about that, each chunk is called a partition. We can maintain and do things with those for tables as well. So that's part of the DDL, which of course in a standard relational database would not be part of it. The other thing I want to talk about is, in this scenario, I'm demonstrating using open source Spark. I wanted to really demonstrate the differences between that and Databricks because I know it's not clear. Databricks is sort of a wrapper around Spark, but there's an awful lot of enhancements and goodies that go with that you may lose the sense of what are the differences. And I find as I do this, it's actually educational for me as well sometimes, because I'm surprised at some of the nuances. Nothing significant, especially when it comes to Spark SQL, which is part of the raw Spark engine, if you will, but there are some nuances. So what I'm going to be using for the demonstration is something I'm really glad, fortunately, for Azure and HD Insight, which is they have support built in for using Zeppelin Notebooks with your cluster, which is great because Zeppelin Notebooks look eerily like Databricks notebooks. So I'm guessing Databricks did something because their notebooks look very similar. And so I want to use Zeppelin because they are good notebooks. They give you visualizations and things right within the notebook. So what are these nuances? First of all, this is more a nuance of the fact that we're using HD Insight Spark. And generally when you're using a PaaS sort of Spark implementation, I'm guessing this is similar in other clouds, but I haven't used the other ones to prove this. I need to import and export my notebooks because I want to make sure I have a separate copy of them other than just on the cluster. Whereas Databricks allows you to terminate clusters, in fact, it can have an auto-terminate setting of a certain amount of time, and those clusters go completely away, but you can bring them back with a click of a button. It's kind of like a pause, but it's really deleting the cluster. Unfortunately, HD Insight does not have any such feature. You can scale a cluster up and down, but you cannot get rid of it, which means you're going to be paying for that cluster until you delete it. And because of that, and because I don't want to have to keep paying when I'm done with my lesson here, I'm going to import and export notebooks and show you how to do the same so that you can play with things. Now, I have been impressed with the fact that if you only want to go in and play a couple of hours, it told me it costs under $3 per hour to use the cluster. So that's not too bad. I don't want to forget about it for too long, but I can pay a few bucks to get into the cluster and use it. The other thing that surprised me is that if you've used SQL, even in like SQL Server or Oracle, typically a semicolon at the end of a SQL statement is how you terminate the statement, and you can sort of put multiple statements in the same block of code by separating them with semicolons. If you've seen the Databricks video I did in video 7, I actually demonstrated that, and it works on Databricks notebooks. It does not work when you're doing Zeppelin notebooks. I'm not sure why, but I did look around and nothing really could clarify exactly why, but it seems to be the way Zeppelin wants to run things in parallel. So if you try to do two different statements, it actually wants to run those statements separately in parallel. So you really need to run your statements in separate code blocks. And we'll see what I mean by that. So the idea is we cannot run multiple SQL statements in a cell, and it does not like the semicolon at all. Finally, I want to show you how you can go into the Zeppelin notebooks on HD Insight at least and make changes to the interpretive settings. The one I really want to change is one that has to do with table display column config. By default, it doesn't even have a setting for this, but the zeppelin.libby.spark SQL field truncate, I can set that to false, and then it won't truncate my columns. Without it, the columns get truncated really pretty narrow, so it's a problem when you're doing things. All right, so here we are in my HD Insight Spark cluster, and we can see we've got a lot of things, and one of the things I mentioned was we cannot just pause a cluster. Now, one of the things I also noticed is this is as minimal a cluster. The only part of this I had control over was this worker nodes. I probably could have gone as low as 1 worker node, but that seemed kind of silly, so I went with 2. But I do want to call your attention to the fact that I've got 8 core used for the head node, 8 core used for the worker node, and then I have Zookeeper, which kind of is coordinating all the resources. That's another 2 core. And there's 128 gigabytes of RAM and another 4 gigabytes for Zookeeper. So this is not a trivial amount of resources I'm using. It seems like, but I'm not sure, but it looks like when you use a Databricks cluster, you can get resources to be a lot smaller than this. So it is one of the things to be aware of. Now, you've got some different things you can use. I could do a Jupyter notebook, but I'm going to use Zeppelin. That's what I want to stick with for this series because I really like the notebooks, and I'm getting used to them over Jupyter. It's not my native home, but I do like these notebooks. And honestly, I couldn't get them working on my own machine too well because it looks like in order to get Zeppelin running for yourself, you have to bring the code down and compile it and do all this stuff. And I'm a little lazy for that, so I'm letting HD Insight take care of this. So let me open up a Zeppelin notebook. And one of the things I did when I created it is I had to create an account, an admin account. Is the one I need to go into, get into my cluster. So when you create your HD Insight cluster or your Spark cluster, there is an admin account. Make sure you know what that is and what the password is because you're going to need it to get into this the Zeppelin notebooks. Okay. Now we're on the cluster. You can see here I've got a Zeppelin notebook. I can do PySpark and all these different things. What I'm going to do is say import a note, and then here I can say choose a JSON file. Again, as I mentioned, it's just a JSON. You can say JSON, J-S-O-N. Going to pick that, open it. Okay, and you can see now it's showing up. Now let me increase this a little bit so we can see better. So I'm going to open, just click on that now that I've imported it. And you can see this is not too different than other notebooks you've used. If you've used Databricks, it'll look very eerily familiar. But if you use even Jupyter, it's not too different. So here, up here you have sort of things that are designed to control the overall notebook, but within each notebook you have some things here. For instance, this can hide output, etc. This can show the editor and all these different things. And the little run arrow, this little arrow here will run a cell. So I've got some links here. You can see that Spark SQL, if I click that, that'll bring me to information about Spark SQL. And here's information on this link on using Zeppelin notebooks. So let's jump in. Now, one of the things that you will notice is I need to put a magic command. I'm going to bring that up a bit. So I'm going to need the %SQL magic, or you can have %libby2.sql, and then do a statement like create a database. In this case, I'm creating MyDB. So let's run that. And it can take a little while when you first start to get running. It'll say running, and then it seems to pause a bit. So let's let that run. And while that's running, you can also, I'm going to start the next one to run because it helps speed this up a bit. But the next one I'm going to do is I've created the database. Now what I want to do is switch the context to the database. Meaning, if you've used relational databases like SQL Server, you can say use and the database name, and then it means that I don't have to keep referring to the database as part of the name. For instance, you can refer to it like mydb.table name, but if I say use mydb first, it will already assume that it is already in that context. It's kind of like switching folders. The other thing I want to point out is that databases are not true databases on Spark. They're really like namespaces. The easiest way to think of it is think of it more like you have a folder. So now that that's run, I'm going to run this use statement. Okay, and that's just finished. And by the way, when you see this sort of block, you can drag that up and try to shrink some of the white space. It creates an awful lot of white space in Zeppelin Notebooks. Now I want to do a show tables, which means list the tables in the database. I can, if I do it with the from, I can specify the database I want to see. So let me try it that way first. I want to see tables in MyDB. There's nothing. I can also, since I did the use statement, I don't need to say from. I could just do this, and it will work the same. But if I wanted to look at a different database, then I could say from and give it a different database. Or if I didn't want to do the use statement first. What I want to do here is say, describe the database, MyDB. What does that do? It gives me some attributes, the name, the description, and then notice it has this strange thing here, HD Insights, but it gets cut off. That's one of the places we want to modify the interpreter settings so that it does not cut off these columns. So what we can do to do that is go way up here. Oops, actually we don't. We can just go up here, go to interpreter, and in here we can see all the different settings for the interpreter. We want to get down to Libby, so we're using Libby 2. And what I want to do here is, these are settings I could change. What I'm going to do is say edit. I'm going to leave the existing settings. Okay, so what I want to do is I need to put this value here. Zeppelin Libby Spark SQL field truncate. And then here I want to say false. Once that looks good, there it is. And what I need to then do is say save. Okay. Let's go back to our notebook. And I'm going to re-execute the use my DB just to make sure that I am in the right database. We didn't lose our settings for that. All right, so let's just rerun the describe database statement. And what you notice now is that this is the full width. So that was the big takeaway of what I wanted to show you there. Okay, the other thing we can do is describe database extended. So if we add this word extended, we'll get more details about the database. We look down here, the biggest thing in a database is that we'll get properties. And those properties are essentially key value pairs we can assign to document things about the database. So what I want to do here is use the alter database statement to set DB properties and say production equal true. So if I run that, it runs the alter statement, and then I can do a describe here. And I need the extended, but the extended will show me what I added. So there's my property that I assigned, production true. So we can see that using properties could be a way to indicate this is production, this is dev, this is test, etc. So it's kind of a nice way to add things. You could even put things like cost centers that pay for this cluster, etc. All right. Now, what I want to do here is, again, always at the top we have the magic SQL. And what I want to do here is say, okay, I'm going to create a table. And I'm telling it there's 3 columns, name, age, and city. Name is a string, age is an integer, and city is a string. And I'm going to add table properties this time. Created by user, Brian, and created date. Let's run this. Okay, and let's check it out. Let's show the table properties. And we can see those things came out. Now let's go down here. And what I want to do here is say, what if I only wanted to look at one property? So I'm going to look at created by user. Let's run this. And that just allows me to select a specific value. Okay. And if I do extended, I can also do extended as we did on database earlier. I can say describe table extended, and I'll get a lot of information, things that we probably didn't even know were there to look at. So lots of interesting stuff there, including our table properties right here. Now what I want to do is use the alter table. So typically in SQL, alter is used to change database objects. And those objects must already exist or you can't do the alter statement. So here we're going to say alter table, my table, which we created. We're going to rename it to my table 2. So let's run that. Now the alter table is fairly limited, so we can add columns, we can make some changes through it to the columns, or we can rename the table. Not a lot of stuff we can do. What I want to do now is alter table, and I'm going to say add column. This time I'm going to add these 2 columns to it. So I'm going to add columns, add 2 columns, a title, which is a string, and a DOB, date of birth, which is a timestamp. And let's describe the table to see if it worked. All right, what we can see is we now have name, age, city, and yep, just what we wanted, title and date of birth. Great. Now, something that we saw when we did the Databricks notebook is we were able to do an alter table statement and modify a column, and all I really wanted to do was add a comment. So in Databricks, this worked fine, this type of format. It was a different table, but all I should have had to do is say alter table, table name, and then alter column, and then say the column name, and then put a comment on it. But the Zeppelin notebook did not like this, and it may be because HD Insight is up to like 2.67, somewhere there, of the version of Spark, whereas when I'm on Databricks it seemed to be more current. So that could be a part of it, because I think Databricks is up to 3.0, which is a lot of changes. But the point here is, one of it is the standard supports both an alter a second time here, or instead of alter change. Now I found that it didn't like it unless I put change here instead of alter the second time. The other thing that was a bit strange is I had to put city, the column name, twice. So it's like change city, and then the new definition is city. String was already there, but I had to give it that, otherwise it gave me errors. And all I really wanted to do was put this comment on it. If I run that, it works fine. If I go here, I can now see, you can see the comment came up. But my point in this syntax is you may have some nuances in the SQL syntax. So just be aware, look at the documentation. I put a link on Zeppelin documentation. I had to kind of look around a lot and just kind of play with it to get things to work. So there are some odd nuances, and it seems to be related more to Livy and Zeppelin notebooks than probably other things in general. But just be aware. But things do work, so it's not a huge thing. Now what I can also do is say alter table, and now I'm going to say set table properties, and I want to put a property in there, sensitive data equal false. So imagine maybe it's got PII, personal identifying information, and you might want to mark a table as like, yeah, this does or doesn't. So this would say, nope, there's no personal information in there that you have to worry about. We can then go check it, and when we describe table extended, we can see, if we scroll down here, that we have now this sensitive data is tacked onto this. So we're able to put properties on, and it's kind of a nice feature. Again, that's just a Spark SQL feature. One of the things we can do, we're not going to be able to see that now because we're not using a partition table. We'd have to do a little more work to get that to be the case. But here what we're going to do is say show partitions, and let's see what happens. This would show us, if we had partitions, it would show us those. Now it's telling us we can't do this because we don't have a partition table. But that's okay. It says it's not partitioned. Later on, we may see something where we have a partition table, then we can see it. But I did want to show you that you can do things with partitions with the Spark SQL DDL. So now we're going to do show table properties again, my table 2, and shows the properties. And the other thing, of course, I wanted to show you is we really did rename it to my table 2. Okay. One thing we can also do is say show functions. And if we say show functions, we can see that it shows us all the different functions related to the database, things we can use in our SQL. So that's kind of handy. And this statement I wanted to show you with the semicolon, this will not work. If I try to run this, you'll see that it just doesn't work. It says mismatch input, semicolon. So I found no matter what I did, it just did not like that. Now I can say show tables from MyDB as we mentioned. So again, I can do something like this. And we can see that now it's showing my table 2 because we renamed it. Now one of the things I'd like to do now is get rid of the database. I don't want it anymore. So I can do that by saying drop database. I like to use if exists because if for some reason you run a statement and the object doesn't exist, like drop, you say drop table, drop database, it gives you an error if it doesn't exist. But if you say drop database if exists, it really kind of inverts as if this exists, then drop it. So it's kind of handy that way because in notebooks, especially if you're running them in sort of an automated way, which you typically would be doing, you don't want to really get a lot of errors kicking out and things like that because people will think it's failing. But in reality, it might not. It's probably fine. So we're going to say drop the database. Now we got an error, and that was intentional because one of the things you see is database MyDB is not empty. That's kind of good to know. We didn't want to delete it. There's something in there. So before we can delete it, we're going to have to get rid of our my table 2. So we're going to do drop table if exists my table 2. And if all went well, we should be able to now drop the database. And that looks good. So wrapping up, we learned that DDL statements, data definition language, create, modify, drop, or query database objects. We learned that database objects include database, tables, views, and properties. We didn't do views here, but we will use views later. Views are really just saved queries that you give a name, like a table to. So you give a table name to them, but it's really a view name, and it just runs the query for you. But we're going to see that later on anyway. We also saw that we can do things with partitions. I did the show partitions. There's more work because when you do partitions, you really have to save the data, persist it. We were using tables and things, but we actually weren't doing anything with data yet. So when we do get into things and we have a lot of data, we can do things where we persist the data and then partition it. But we did see the show partitions part of that. So at least we can see that, yeah, DDL does include that. And we talked somewhat about the nuances. The biggest nuance that took me a while to kind of trace down was putting that fix in so that it would display the column widths correctly so we didn't get truncated data. Aside from that, we also noticed that the semicolon does not work on Zeppelin Notebooks on Apache Spark. And we don't really know why. If I find an answer, or if you know it, post it in the comments and I can bring it up in another video. So that's really about it. I hope this was useful. I hope you liked it. And again, it's interesting because I did almost the exact video on a Databricks notebook, but I wanted to really do this thing in parallel with Apache Spark, which I hope is useful because there are some differences. They're close to identical in many cases, but the devil's in the details, right? It gets tricky sometimes, the little nuances. I even hit some here that did take me a little time to figure out why isn't this just working. So I hope that was useful. Subscribe, like, share, and I hope, put comments. I always like to read those and see what people are getting out of this. Until next time, I'm pulling for you. We're all in this together. Thank you.